This is practice problem number 2 for lesson 5, Introduction to Linear Relationships. In this problem, you're asked to figure out how much it costs to have your house painted. And so what the painting company does is they charge you $500 for the supplies. So before they ever even paint anything on your house, you have to pay them $500 so they can get the supplies to paint the house. And they are going to charge you $50 for every hour that they work on your house. So this is a flat rate, $500 for the supplies. So no matter how long they work, you have to pay that rate. You have to pay that $500. So regardless of the hours the painters work, you have to pay $500 for their supplies. This is similar to problem number 1, the pizza problem, in which there was a delivery fee of $3. You had to actually figure out what that delivery fee was in problem number 1. But it turns out that it's $3. That's a flat rate for however many pizzas you order or have delivered. You have to pay $3. That's similar to the $500 for the supplies. But in this problem, that number is given to you. So the beginning amount is $500. You also have to pay $50 for each hour that they spend painting your house. So it's $50 for each hour. And that's similar to problem number 1, in that the cost of the pizza was $11 per pizza. And again, you had to calculate that in problem number 1. In problem number 2, that's given to you. It's $50 per hour. That's a number that's given to you. So it's like the cost per pizza in the first problem. So $50 per hour of work. All right, so I put together a table, and I'm going to go through that. In the first piece of information, there are basically 4 components to figuring out these linear relationship type problems. And the first component is, what are the properties? What's going on? What are the 2 things involved? And one of them is the cost or the charges for painting the house. And the second is, how many hours do they spend painting that house? So that's the first component. The second component is there a charge up front? Is there a charge before they ever begin working on the house? And there is. That's $500 for the supplies. So we're going to put this together in a table. What's the third component? Which is that cost per hour working on the house. It's $50 per hour to work on the house. And finally, the fourth component is, what's the total cost? All right, so we've done the work, we paid the flat rate, we've worked so many hours. How much is that going to cost us? So if you work 20 hours, how much does that cost? If you work 50 hours, how much does that cost? So this table, now I put together a separate video on how I created the table, the kind of thinking that went into identifying those 4 components of linear relationships. So we're just going to use that table in this case. So what are the 2 properties? Those 2 properties, I just listed them for you. So you just fill in this table. It's the cost and the hours of labor. Is there an amount when x is equal to 0? So when x is 0, in other words, there have been no hours spent painting the house, is there a value along the y-axis? And there is. That's this $500 that's given to you. Is there a rate of change? Is there a unit rate or a slope rate of change? Those are all the same things. Is there something that's changing the same each time? And there is. For every hour that you work, you have to pay $50. So that is the rate of change. And is there a total amount of one of the properties? In that case, is there a total amount of the total cost of doing the work? And that you have to calculate. That's the problem. So if they work 20 hours, what's your total cost? If they work 50 hours, what is your total cost? So that's the problem that you're going to figure out. But this gives you all the information that you're given in the problem in an organized way. So a way that you can look at it and then use it. All right, so let's go back. So the cost of painting the house is $50 per hour. And the first question is, what if they take 20 hours to paint that house? Well, if you look at just these 2 parts of the problem, that's like y equals kx. That's like the proportional relationships that we worked with earlier. So the cost of just $50 per hour times 20 hours, you could call that the labor costs. If you It's the cost of, actually it's the cost of doing the labor on the house. So it's $50 per hour times 20 hours. So the labor cost is $1,000. But there is an additional cost, and we know that there is. That's the $500 for the supplies. So you have to add that to your labor cost. So the total cost is being $1,500. Now this equation is going to change. We're going to add that supply cost onto this equation, and you're going to see that in a little while. All right, the second problem. So if you approach it the same way, it's $50 per hour times 50 hours. So I work 50 hours. Every hour I'm getting paid $50. So that's 50 times 50 is 5 times 5 is 25 times this 100 here, 10 times 10. It gives you $2,500 or $2,500. So I'm using this equation to begin with, but then we have to add that beginning amount, which is $500. So this is the labor cost plus the materials cost, or the supplies. So you add those two together, it's going to cost you $3,000 to get that house painted if it takes 50 hours. So now we can put it on a graph. You have to begin with the $500, or a way to begin is the $500 that you have to pay up front. You know that's 0 hours worked on the house, but you have to pay $500 for the supplies. Now to get to $1,000, they divide this into 6 parts. 1, 2, 3, 4, 5, 6. That means halfway up is the $500. So you put a point right there for $500. And also for 20 hours, we calculated that cost $1,500. So you put a point right here for 20 hours of work, costing you $1,500. We also calculated that 50 hours cost $3,000. So you put a point up here at $3,000, where it's 50 hours of work, and all 3 of those points fall in a straight line. It is a linear relationship. It falls on a straight line. So 50 hours, 20 hours, 0 hours. Fall in a straight line. And we can use this equation, y equals kx. But remember, you have to now add this $500. That's the beginning amount. So we're just going to call that B for beginning amount. And if you include that in this equation up here, it's y is equal to 50x. So 50 times $50 per hour times the number of hours worked plus the $500. So this is filling in the parts of the equation. And if you work any number of hours, you complete this equation to get the total cost. All right, so can we see the slope from this line? And certainly we can. So if we move the slope triangle all the way over to the y-axis, and it's convenient in this case to use 10 hours as the length along the horizontal axis. It's too small to use 1 hour. So let's use 10 hours. And 10 hours costs you how much? Well, that's going to cost you $500. So you work 10 hours, you have to pay $500. They work 10 hours, you pay $500. They work 10 hours, you pay $500. So that's the slope. So it's the number of units in the vertical direction compared to the number of units in the horizontal direction. So let's go back to what we've learned a while ago. So that's 500 units in the vertical direction compared to 10 units in the horizontal direction. So that's 50 times. So the number of units in the vertical direction is 50 times. That 50 right here, or that 50 right here, is 50 times the number of units in the horizontal direction. Well, 50 times 10 is this 500. So it's $50 for 1 hour of work. And where does that show up in the equation? It shows up right here. $50 per hour times the number of hours plus $500 for the supplies is going to give you your total cost, or the value of y, which is on this y-axis this way. So $500, $1,500, and $3,000 if you use those 3 points. All right, so this is problem number 2. And look at the video on the 4 components of linear relationships to see how to use that table and how I put together the thinking that went behind putting that table together.